Right. Good day, grade 12s. We are here again on the second episode of Electrolytic cells, which I initially started by saying that is the last question on physical sciences paper 2 for national paper, grade 12. So I'm back with the questions. We want to look at different types of questions, what is expected from a learner, and what is expected by the markers when they are marking this section of the paper. I did mention that it is very easy and straightforward, and it needs one to remember all the 5 processes I've mentioned earlier on my first episode when I was talking about electrolytic cells. So what we want to do now, we want to look into questions, then we can unpack the questions, then we can explain what is expected from those questions. So what I'm having in front of you here is a question, all right, that was extracted from a question paper. So we just want to look at the questions, and we are also going to come up with the solutions. So the question starts by saying an attractive silver appearance can be created by electroplating artifacts, objects made from the cheaper metals, such as nickel with silver. The simplified diagram here represents an arrangement that can be used to electroplate a nickel artifact with silver. Now, grade 12, we were discussing this content earlier on. I did mention to you that electroplating, it is a process whereby you are coating one metal using another metal. So it is a process whereby we are trying to improve the appearance of another metal. So this is one of those questions we need to apply and solve the question. So I'm looking at the setup with electrode 1. I also have the silver solution there, and I also have electrode X. So the first question that they are asking is, which electrode, whether is it the cathode or the anode, does the nickel artifact represent? So grade 12, remember we also said that in this time around, whenever you're dealing with electrolytic cells, that the anode is now positive and the cathode is now negative. So the examiner is asking here to say which electrode, is it the cathode or the anode, where the silver artifact will be going to. So we are looking at cathode. That is the answer that we were expecting. Which electrode does the nickel artifact represent? They represent the cathode. Very, very important. We are moving to question number 2. The question says, name the metal that is represented by electrode Y. So I'm looking at my diagram there. I'm seeing that there's electrode Y and silver solution and electrode X. So name the metal that is represented by electrode Y. The answer will be silver. You can remark. Simple and straightforward. I can even show you the solution here. So, next question. Number 3. It says that write down the half reaction that is responsible for the change that occurs at the surface of the artifact. So what I've realized is that, when you're dealing with electroplating, when oxidation and reduction are taking place, they are taking place on the same metal. So in this case, we are saying if electrode Y is silver, chances are the half reaction they are looking for that is responsible for the changes that are occurring on the surface of the artifact, that should be silver. So if you check the half reaction on your standard reduction potential table, it says it is Ag plus electron, which equals to silver. Very, very important, grade 12. Right. Let's move to question number 4. The question says, give a reason why the concentration of the electrolyte remains constant during electroplating. I mean, this is different from galvanic cell because of we are saying the concentration of the electrolyte, which is the solution that conducts electricity. Why should it remain constant during electroplating? Here's the reason for it all. The rate of oxidation of silver at the anode should be equal to the rate of the reduction of silver at the cathode side. Remember, oxidation and reduction are taking place simultaneously. So as a result, why are we saying the solution of electrolyte, why should it remain constant? Simply because the rate of oxidation of silver that is taking place in the anode should be equal to the rate of the reduction of silver that is taking place on the cathode side. I believe it's very clear, grade 12. Let's move to the next question. Number 5. In industries, some plastics articles are sometimes electroplated. This is a question. In industry, some plastic articles are sometimes electroplated. Explain why the plastic must be coated with a graphite before electroplating. I was very clear when we started with this section to say we mainly use carbon or graphite simply because of they are inert. So now they are asking a question. In industries, some articles are electroplated. The question is why? Why? It is because plastic is a non-conductor. Plastic is a non-conductor. It must be covered with a conducting layer so that it can act as a cathode. Therefore, graphite is a conductor. I repeat, the reason they're saying plastic needs to be coated before it is electroplated, it is because when electroplating is taking place, we really need 2 electrodes, meaning we need 2 conductors. So plastic is a non-conductor. Therefore, it must be covered with a conducting layer so that it can act as a cathode. That is the main reason. So let's check the last question. It says, give a reason why, from a business point of view, it is not advisable to plate aluminium with silver. So from a business point of view, it is not why it is not advisable to coat platinum with silver. This is an open-ended question. That means a learner can give us an answer that is valid. So what we normally do is we are obviously going to have expected answers. 1, platinum is expensive. That is very true. Platinum is expensive. 2, it is more durable than other metals. Therefore, you normally electroplate a cheap metal with an expensive durable metal, not the other way around. So the examiner here was trying to provoke us whether do we really understand that there's no way that you can coat an expensive material with a cheap material. It's always the other way around where you need to coat an expensive material with a cheap material. Grade 12, these are the 6 questions that were asked in this question paper, and everything that we have explained here, it is part of what we shared when we're looking at the questions here. So what am I saying? I'm trying to say whenever you are tackling such kind of questions, you really need to have your notes, you really need to have your content ready, you really need to have all the resources that you need in order for you to answer these famous questions that they normally ask. Now, let's look at another question paper, a different one. So, I'm realizing that this question is totally different from what we were doing. The previous question was looking at electroplating as one of the industrial processes that we were talking about earlier. This one, it is focusing on the purification of copper. So what I'm going to ask you to do is get your content ready when it comes to purification. Let's solve this question together. It says the impure copper can be purified by the process of electrolysis. So what they are giving us here is the simplified diagram that represents this electrolytic cell used to purify copper. So let's check the question, grade 12. We are looking at electrodes P and Q with an ammeter there on top, with a battery also there on top. Then these electrodes P and Q, we also realize that there is an electrolyte, which is a solution there as copper sulfate. Then there are questions, 6 questions again, grade 12. Let us respond to these questions. The first question is define the term electrolysis. What is electrolysis? We can only get this definition in the exam guideline. So, electrolysis is a process during which electrical energy is converted to chemical energy. It is a process in which electricity is used to bring about a chemical change or decompose or break compounds into components. So this is a very good definition because of what it does. It breaks down and it explains everything that is involved here. So grade 12, we are looking at electrolysis as a process during which electrical energy is being converted to chemical change. So if you've went through the previous notes that you and I were sharing, you will realize that when we were talking about electrolytic cells, I started by saying you must understand the energy conversion that is around it there. So we are looking at electrical being converted to chemical. Electrical to chemical. Next question. Which electrode between P or Q that consists of impure copper? And I want you to pay attention on the charges that the battery is offering us. That on Q, there is a negative terminal that is connected there. On P, there is a positive terminal that is connected there. So those things are going to help you to explain how you arrived to the answer. All right, so let's find out which electrode, P or Q. So in this case, we are going to say P is the one that is having impure substances. Why are we saying so? Because of P is a positive electrode. And what is the meaning of positive electrode? It means that we are looking at anode. When we are looking at anode, we are looking at this copper or this anode, a substance is being oxidized. So what we are saying is that the impure copper is oxidized at the positive electrode. So grade 12, just to put a stamp into this thing, I want you to understand that whenever we are looking for the side which may consist of an impure, or how to differentiate between the impure and the pure substances, you must understand that impure will be located on the anode side. And anode side is the positive side, because on the positive side, that's where a substance will be oxidized. Very, 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 very important for you to understand that. Next question. The question is, write down the half reaction that takes place at the cathode. Now, grade 12, I want you to look at the 2 electrodes. We have electrode P and electrode Q. So what we're looking at you showing us the purification of copper using Copper. So what you normally do there, you write the half reaction of copper. So you get that in the standard reduction potential table. So you go there to standard reduction potential table. You see that we said P is the positive, which means it's the anode. So that's where we are going to get oxidation. You're going to go and take the half reaction, which is Cu2 plus 2 electron, that is equals to your oxidation. But if you look at to electrode number Q, which is our cathode side, we still use the same substance. But remember, we are saying the difference between oxidation and reduction. Whenever you are writing the half reaction, for oxidation, the electron should be just after the arrow. But if you're writing a half reaction of a reduction, the electrons must be before the arrow. So basically here, you were being asked to write the two half reactions, which of the same substance, but just putting the location of the electron in different positions. So, next question. So, let's look at the questions again. We're being asked to compare between platinum and silver. That was the question that they were asking us on number 4. So, the solution that we're looking at is every time when you're being asked to compare silver and platinum, in fact, this is the same question that we dealt with on the previous question to say, why can't we coat a platinum with silver? That was the question. And they asked us to respond based on the business point of view. But they are changing the question right now. They are asking again the similar question, but using different phrase. So the solution is still the same. Platinum and silver, they are both weaker reducing agent than copper and will not be oxidized to form ions. So what are we saying grade 12 here? We are saying whenever you are looking at platinum and silver, compare to it with copper, platinum and silver, they are both weaker reducing agents than copper. Therefore, it will not be oxidized to form ions. Very, very important. We can just look at the last two. It also says the rate at which copper is being oxidized at the anode is equal to the rate of which copper ions are being reduced at the cathode. We have seen this reason before. We now know this reason before because of what they are saying. The question is always focusing on why the solution, it is remaining constant in the reaction. Why they are asking about the calcium sulfate solution or the electrolyte, why should it always remain constant during the reaction? It's because those two electrodes that you and I are having on the beaker, one has to perform a oxidation, one has to perform a reduction. So between those two, there's no way that the concentration of the solution can decrease or be halved or be reduced simply because of we need the electrode to be we need the electrode to be coated or to be purified evenly so that's why we need the rate of the forward to be equal to the rate of the reverse, meaning the rate of what is happening on the oxidation should be the same as the rate of the reverse. And then last question, we have seen this reason again before. Silver and platinum are valuable and expensive metals and can therefore be sold at a profit. So let me just help you there so that you understand what is happening. So the question is, we now know that if you look into copper refining, we said a sludge or residues of metals are always remaining behind. So the question is, why is the sludge of economic importance? We said the same sludge because of there are pieces of metals they could be sold. That's why there's a question, why is the sludge of economic importance? Is because of those residues, those decomposed metals they can be sold. So big companies, they take these residues and sell it to other companies because of they contain ingredients and different types of metals in it. So we normally use it for those purposes. There are other industries that take those residues and make use of them. The likes of Sasol companies. So why is it of economic importance? If a company has residues and they were refining copper, they can sell them. Then number 5, just to take you back, the question was explain why the concentration of copper sulfate remains constant. I did say this is because of the rate of the anode should be equal to the rate of the cathode. Very, very important. And then just to take it back to number 4 again, it says during the purification, metals such as silver and platinum, they form a sludge at the bottom of the container. Refer to the relative strength of the reducing agents to explain why the two metals do not form ions during purification process. I did mention that it is because platinum and silver, they are weak reducing agents compared to copper. So grade 12, we are looking at this question paper. There were 6 questions, plus minus around 12 marks in the examination. So if you know that you are collecting marks all the way from question 1 and you get up to this last question paper, last question on the question paper, and you understand what you are doing here, there's nothing that is limiting you in getting the actual marks. So grade 12, these are the questions that we normally deal with. Till we meet again next time when we discuss another content, another topic, and we're also going to look at the questions. But for today, we'll leave it here. Thank you so much.